Hi everyone, welcome back to another Matlab tutorial. In this section we're going to look at one of the main branches that we'll be using for the rest of the course, also known as an if statement. But there are two different types of branches. The first one is the if statement, also known as an if-else-if-else construct, and then there's also the switch statement. So let's start with diving pretty deep into what an if statement actually does. If we look at this flow chart and you imagine that the gray triangle or the gray diamond on the top left where it says if statement is where Matlab begins the construct. So we may say something like if x is less than 5, go do this. So notice that there's two lines coming away from that statement, one being true and one being false. If it's true, then we tell Matlab, okay, go execute these lines of code, and then finish. But if it wasn't true, maybe there's a secondary question. These secondary questions are called else-if statements. Else-if meaning, well, it did not meet the original if statement, but it may meet one of these statements. And you can have as many else-if statements as you want. It can be 50 else-if statements, or it could just be one, or it could be 0. So if it did not meet the if statement, then it's going to come down to another question. Say, okay, well, if x wasn't less than that value, is it at least less than this value? Maybe you have a new logical statement here, and if that's true, then we follow these group 2 commands. And if it's not true, then maybe it falls into an else category. This is essentially a catch-all. It didn't meet any of the criteria from the if statement or the else if statement, so we want it to do this instead. Now keep in mind, you may just have an if statement by itself. You may have an if statement with a few else if statements, or an if statement with just an else statement and no else if statements. You can essentially structure it how you want. The important thing, and we'll look at an example in just a minute here, is that it must start with the word if, and at the very bottom it must end with the word end. So let's see what it actually looks like. Now this looks a little bit overwhelming, but let's break it down real quick. In the first lecture, we talked about logic, control and rational logical operators, where we say x is greater than 5 or 3 is less than 1. Those are the control expressions that you see here. So notice this construct, we have an if statement, then a few lines down an else if statement, a few lines down an else, and then we finish the entire structure with the word end. And notice within each if or else if or else, there's statements. This is just executable code. This equation, or fprintf this, or display this, it could be absolutely anything. But notice that only the if and the else if require control expressions. Whenever it has the word if in it, it must be a question to Matlab. If this array is greater than this. So let's look at our first example. You might recognize some of these on the screen of general grades between a letter grade and a percentage in a class. So we're going to write a script that reads in a numerical grade, maybe from the user, and it returns a letter grade using this scale. This scale is a little bit, I'll call it cruel. I do not require a 95% for an A in the class, but let's look at it for the sake of it anyway. We'll say that greater than a 95 is an A, an 86 to a 95 is a B, and so on all the way to a 0 to a 65 being an F. And what do those steps look like? We can create one of our pseudocodes. So we'll say step 1, we're going to ask the user, using our input function, to enter a score. This will be a numerical value between 0 and 100. And then we're going to construct an if-else-if-else statement to determine the letter grade. And then we'll display the letter grade using the display function. We don't have to worry about designing a flowchart for this. So let's open up Matlab. And I'm going to create a new script here. And we can say that grade is equal to the input function. Enter your score from 0 to 100. So now we know the grade, and we have to get Matlab to respond to us with the letter grade, A, B, C, D, or F. So we start our if statement by typing the word if. And after if, we need a control expression. We need to be asking Matlab a question here. So we can say if our grade is greater than 95, then the output is equal to the letter A. Now, we can only use the word if a single time in each construct. But we have more options. We have a B, C, D, and F. So we need to use the else if, and it's all one word. Else if grade is greater than 85, then out is equal to B. Notice when we used else if, we also needed a logical question here for Matlab to answer. And we can repeat the else ifs as many times as we want. If it's greater than 75, then out is equal to C. Else if the grade is greater than 65, then out is equal to D. And now we have no other options but F. So we know that it's not greater than 95, 85, 75, or 65. So whatever value was entered has to be lower than 65. So really on this last one, we don't need an else if statement. We could just say else. And out is equal to F. And then to finish it, notice that there's a red squiggly line next to the if. It says an end might be missing. And yes, that's true. If we want to complete our construct, we need to put the end symbol. And then we said at the very end we would display out. And we can make it fancier if we want. Maybe we say the letter grade is out. I think that should work. So we'll save the code as if example. So we'll enter our score from 0 to 100. Let's say we got an 80. That should be, I think it's a C. Yeah, the letter grade is a C. And we can run it multiple times to make sure that we got the values correctly. Maybe we'll add a 97. Your letter grade is an A, and so on. So your answer might look something like this. It might look something different, but overall, this is how the construct would work. Now you may have asked, why don't I need to put both on here? For this first else if, we say, well, if the grade's less than 95 and the grade is greater than 86. Well, we already know that it's less than 95 because it did not meet the first if statement up here. So you really only need one at a time. Why can I keep using the same variable out? Well, because Matlab is only going to go to one of these. It's not going to go to each one. These types of constructs tell Matlab to skip around a little bit. As I mentioned before, logic gives Matlab the opportunity to kind of go where it needs to go versus what we've done in the past of Matlab executing every single line of code. Matlab's only going to see the word out being declared as a variable one time, even though we have it listed as 5 times. Now I want to talk a little bit about math book notation. Many of you have probably seen something like this in red where it says 86 less than x less than 96. We all know what that means. It means that x is somewhere between 86 and 96, right? Well, we can't follow that same logic in Matlab because it could fail. Sometimes it works, sometimes it does not work. Let's look at an example here. So what we're saying is that if we applied the same logic to the last example of 86 less than or equal to grade less than or equal to 96, it's not the same as doing it what's on the right, which is the proper way. essentially asking two questions here. So you need to give MATLAB two logical operators. Grade is greater than or equal to 86, and grade is less than 96. Do not do what's on the left. Sometimes it will work, sometimes it will not. Let's look at an example of both. Let's say that the grade that was entered was a 90. And if we go through that logic like this is the math book notation where 86 less than equal to 90 less than 96. If we remember the order of operations, what we're really saying is 86 is less than or equal to 90. That's the first question to MATLAB. Notice I've highlighted this first part, 86 less than or equal to 90, and then the 1 on the other side. This is what MATLAB's doing. MATLAB's saying, yes, 86 is less than or equal to 90. That's true. I'm going to put a 1 there. Now I'm going to go evaluate the rest, which is the less than 96. And then it's going to ask that second question. Is 1 less than 96? Yeah, that's true. 1 is less than 96. If we do it the other way, where we say 90 is greater than or equal to 86 and 90 is less than 96, both of those are true. So yeah, in this case, they match. But let's look at an example where it doesn't go that way. Let's say your grade is 80, and you follow the same logic of 86 less than or equal to 80, less than 96. The first thing MATLAB's going to do is look at the expression that's highlighted. Is 86 less than or equal to 80? Yeah, 86 is not less than 80, so it's going to put a 0 there. Then it wants to compare the 0 to the 96. Is 0 less than 96? Yeah, 0 is less than 96, but that's not true from what we wanted, because we wanted to know about the grade. And it gave you a 0 and a 1, where if we did it the right way, where we say is 90 greater than 86 and is 90 less than 96, you have false. And those don't match. So if in the event you want to try to ask MATLAB multiple questions, you cannot do it via the math book notation. You must ask MATLAB separate questions. Now earlier, I asked you to take a look at the ampersand. So let's come back to MATLAB real quick. And I am going to create a random if statement. We'll say enter a value for x. And I'm going to clear my workspace real quick. And we're going to say if x is greater than 4 and x is less than 11, display something, and then end. This is a very simple if statement. And I want you to notice that the ampersand that we used, even though it's correct, is underlined in orange text, which means it will work, but MATLAB is giving us a warning. Let's see what that warning says. When both arguments are numeric scalars, consider replacing the ampersand with 2 ampersands for performance. What does that mean? What is really the difference that's going on here? Well, I'm going to explain. If we use a single ampersand, MATLAB is going to check the left side and the right side of the ampersand every time. But what does the ampersand mean? It means that what's on the left has to be true, and what's on the right has to be true. If the one on the left is not true, it doesn't really matter what's on the right, does it? Well, MATLAB's going to check anyway. It's going to waste time that's not needed. That's where the double ampersand comes in. When we put a double ampersand, what MATLAB does is if the value on the left is not true, it automatically knows that the entire statement is false, and it doesn't even bother going to the other side. Same thing is true when you evaluate an OR statement. The OR statement says I only need one of them to be true. But if the first value is true it still wants to go check the other side, even though it doesn't matter what's on the other side. Whereas if you put a second straight line, Matlab knows, okay, if the first one's true, if the value on the left is true, I don't need to go look at the other side, so I'm not going to. It might not save a whole lot of time or a whole lot of data, but if you imagine you had a very large code, a very large script with thousands or tens of thousands of lines, these types of time and data saving strategies can help just a little bit. We can also have something called a nested if statement. This is where we have an if statement inside of an if statement, sometimes inside of another if statement. There's really no limit to how many if statements you can have. In this course, I don't think we're going to see more than one or two nested if statements. Notice that every time we have the word if, it has a corresponding end associated with it. It doesn't work like the else if in the other example that we did. Every time you have the word if, you must have the word end. Let's see when we can use it. Here's an example where we have f. F is a function of x and y. And depending on the values of x and y, the equation to calculate f changes. So we say if x and y are both less than 0, then f is x squared plus y squared. If x is less than 0, but y is greater than or equal to 0, we have this equation, and so on. So let's create a code that will calculate f based on these values. Let's open up Matlab. And we'll erase all of this. Well, I guess we can leave x, and we can do the same thing for y now. Enter a value for y. And we can say if x is less than 0, and then if y is less than 0, we can put our first equation. And our first equation, I believe, was x squared plus y squared. So we'll say f is equal to x squared plus y squared. But now we're going to put either an else or an else if here. Now this is for the first if statement. So we're saying if we made it to this command, that means x was less than 0. So now we're going to look at when x is less than 0, but y is greater than 0. And it might look something like this. It's just x plus y. Now we can close that first one out. Now we've looked at x is less than 0 for both y less than 0 and y greater than or equal to 0. But now we need to look at when x is greater than or equal to 0. So in the first if statement, we can change that to an else. And we can say, well, if y is less than 0 here. So if x is greater than 0 and y is less than 0, then we have this third equation, x plus y cubed. F is equal to x plus y cubed. And if it doesn't meet that one, then we have the final equation, where x and y are both greater than 0, and we have x cubed plus y. We can close out this statement, and we can close out this statement. Notice we have 3 if statements here, and each if statement requires an end. So we have a large if statement with 2 nested if statements. And we can say something like f print f, the value of f is equal to 8.3f, and let's not forget our percentage sign. And the variable we're looking for here is f. So if we save this code and we call it nested example, enter a value for x we can say is -2, enter a value for y we can say is 3, and we have that the value of f is equal to 1. If we want to double check our numbers, we can run it one more time, And we can say the value for x is minus 2.134. The value for y is minus 2.147. And we get a value of 9.164. So there really is no limit to the amount of if statements that you can put inside of a larger structure. It will all depend on the content of the problem you're trying to solve. Your script might look a little bit different. You might want to put the y's first instead of the x's first. You might want to ask, is x or y greater than, and then have the else statement be something different.